We were in the same ward for like 3 or 4 semesters.
Oh, the same ward hookup.
I know. My husband and I were a singles ward.
I met online. Never thought I would ever do that. But
that wasn't around when I was dating.
My
it
mom.
wasn't about the first time.
My mom grew up with one of the first people to get married through online dating service.
Oh yeah.
Really?
Uh-huh. They're still married from what I know.
Nice. I can't remember the website. I think it was like ldslinkup.com or something like that. I think that's what it was. Oh my gosh, that's hilarious. That's awesome. Oh.
Unfortunately, I haven't gotten very far through the homework. Only to like 12.
I'm not very.
I answered all of them, but I think it was like 3 or something I didn't answer.
Okay.
Oh, sweet, sweet Jack. All right. All right. Let's see here.
Yeah, this homework.
All right, question. Let's see what we got here. So question 2. You got, Stephanie, you got G?
Well, you have to realize there's 4 extra kids screaming around my house, so I couldn't focus. So I
did the same.
I got G
G.
too.
Well then.
And what did you put? You put in this independent sample? Okay, so let's figure out. So there's a
I put G too.
There's a Word document.
I thought it was independent, but.
Did you see the Word document that was on the homework?
The flowchart one?
Yeah, except it's all blank. If it was filled out, it would be really helpful.
Oh, I didn't even look at that. Let me download that bad boy.
We can fill it in. It'd be awesome. So it tells you how you know what statistical test to use.
Oh, I will definitely fill that in then.
Because
I think a lot of them could work.
I know, and this is where I think I get most of them wrong, is on this kind of stuff.
I think I do too.
Okay.
All right. Oh, look at this here. It's like a sheet.
Well, I thought that it was categorical, which is why I put G.
Oh yeah, that's right. We've got to take that into account too.
So categorical, it could be either a 1 sample, a 2 sample, or something else.
Well, it's a 2 sample because it's talking about
2, yeah.
The United States and Korea.
Yeah. Why did I think it was independent? Because they. So yeah, it obviously is. I was independent.
Okay, so.
Do you think it's the test of 2 proportions?
Well, and the only thing I'm thinking of is that's the categorical one. So if is it categorical then for sure? We're testing.
It seems categorical to me.
We're just comparing educational and success, so there's no quantitative.
Yeah, there's no quantities.
And then the other thing that made me think that it was more the categorical is the way it says, we want to see if this successful startup company is independent of the country they are from. I don't know. That's the chi-squared or the chi-squared, right?
And also, yeah, you're right. The wording of the way it says determine if such and such is independent, they use that a lot for the last 2 lessons.
Yeah.
For the categorical ones.
All right, I agree. I think it is G. What'd you get for 3?
D.
Haha, sweet. Well, I got D. Steph, what'd you get for 3?
I'm wiping my greasy chicken off my hand. I didn't get 3. I kind of bounced around. Like I said,
no, it's okay.
I just took focus to here.
You're okay.
You guys put D, independent sample T?
That's the one I have.
Okay. So if it's independent, the samples are not dependent on each other here, right? Okay. Sounds good.
Do you concur with that answer?
I concur.
Yeah.
Sweet. Okay, 4.
I got A for 4.
Oh, I'm looking at 5. 4. I also got A for 4.
Oh, so it's saying it's one sample and paired sample. What does that mean?
I thought it'd just
What
be
is-
one.
Oh, never mind. I threw myself off. You know how it says A, B, C, etc., and then underneath it says A, one sample?
Uh-huh.
Yeah.
I thought that was A was saying it's B and C,
Oh, I see.
etc. I just read it wrong.
That sounds good.
So we're looking at that, just a one sample Z, the difference of. Yeah. Okay. That looks right.
Okay, and I did not answer. What did we get? What did we get to? Well, I did not answer 5.
5, I got B.
One sample T.
Well, I mean, it kind of says he's comparing the two, so I would say it's one sample T test also.
Because the one sample T compares the differences, right?
The differences, uh-huh. Yeah, 25 students for each student was given the combination to be each.
1 second. How are the soy sauce eggs with the wrong? That's good. They've been soaking in the mixture for like, I don't know, half a week.
What do you think, Steph, for 5?
25 students, so we got two different things, 25 students. So that's probably the paired sample, right?
5, I
Yeah,
did one sample T.
Well, the paired is dependent upon each other, right?
Yes.
Yeah,
So those aren't dependent.
and it's not going to be an independent.
Well, it looks like it's just one set of variables, which is why I chose B.
Let's see.
Effectiveness of 2 different combinations.
It's one set of variables, and it's quantitative.
Quantitative, yep. With 25 students.
And we already did A, the Z test, so this is the T test, B.
But it does say that they can be repeated, doesn't it? You may use a
I thought it said that it can't be repeated.
No, you can. You may use a hypothesis more than once.
Yeah, you can use it more than once, and you can even not use some, yeah.
For some reason I thought that it said you can't use it more than once.
So we have two groups testing one thing. It is quantitative.
I always have a hard time distinguishing Z and T. I don't know why.
Yeah,
Well,
no,
the difference is Z is known, sigma known, and T is
yeah,
sigma
is not
unknown.
known. Yeah.
Okay. So maybe it's A again.
Well, it doesn't necessarily say sigma is known, does it? What was?
But if you have all the numbers, then you can get the mean. And if you have all the numbers and the mean, then you can get
You can get this.
sigma.
But it doesn't. It just doesn't.
All the numbers, you can calculate sigma, pretty much.
Let's see.
I don't know. It's either A or B.
probably B. Because it's not saying that sigma's known.
Well, it wouldn't say if sigma's known. Because like I said, if you have all of the data, then you can calculate sigma.
Now, I wish I would have seen this chart, this spreadsheet earlier, because
So one sample. I'm almost thinking it's A.
a z-test
I
Yeah.
am too.
is
But,
sigma known.
What do you think, Steph? Yeah, I don't know though.
I don't know. Seriously, these throw me off so bad. That's the only thing I can tell, because in previous tests, sometimes it will say sigma is known. And other
it
times-
won't say whether or
times
not
it doesn't.
sigma is
So,
known because, like I said, you can calculate sigma if you have all the data. Because they're gathering all of the raw data, so they'll know sigma.
I don't know. I guess it could be either A or B. A questions, I guess. I'd rather have questions where I just have to figure out math stuff.
sorry, I was just trying to look at a couple other things.
What's that?
It says in particular, you should go over the review for exam 1 and exam 2.
Is that what the review thing says?
That's what it says in the review, like the lesson review.
Go over exam 1 and exam 2?
Yeah.
Oh, that's nothing. I mean, I guess there's questions that go back up.
Yeah, I don't, either one. Not bad. I'm not processing it right now to think what it does. Should we go with A?
That's what I'm going to do.
Do you still feel like 4 is A? That one seems like there's a lot of components to it to be a simple Z2. I'm wondering if 4 isn't one of the. Oh no, never mind. I'm rethinking this. Just certain words make me think different things, and I get confused.
Did I miss anything exciting?
Nope.
No, I'm just thinking out loud here. On 4, I was wondering if it was a test of proportions, but that's for categorical. It was just the way it said that they're looking at the lotto players are in different proportion of males, but then we're still looking at numbers, so that's categorical.
Yeah. What did you think about 5?
I don't know, maybe just A. I just can't get my brain to go that in depth right now.
Alright. We can come back to that one. No, it's all good. We can come back to that
I
one.
really need some caffeine, I just don't want it this late at night.
Where's Jake? I thought he said he was coming.
He did, yeah. I think he'll be getting on.
He gets right off work at 8 or 9. It's actually 9 his time.
So 8 on him, yeah.
So sometimes he's a few minutes late because it just depends if his work goes longer. It seems like that's kind of the way it's been.
Yeah.
Okay, so we can just review right before we submit.
Yeah, that's time. We'll come back down.
Number 6.
6.
I had a hard time with 6 through 8.
Because these are the confidence intervals.
Uh-huh. I'm thinking it's C.
Oh, we've already had this question once before.
Make sure this is the case. Wouldn't that be a paired sample?
I did do C.
I think so because they're dependent on each other, right? Because
Yeah, I think it'd be C.
Everybody's doing the same thing. So it would be a paired C. Okay, so 7.
I got F for 7.
Would that be, keep it in the categorical. Yeah, I would think it'd be F. Also.
For the two proportions, right?
Yeah, because we were comparing two things, and it's a categorical, not a quantitative. Number 8.
Double stuff Oreo. I would say that'd be the same one, wouldn't it?
You think it's F?
Shouldn't that be F also?
Well, We don't have two proportions, do we, necessarily?
Possible. I was thinking that was E.
We have kind of a difference of, so we're looking at the one thing and it's just a difference of it to see if it's,
Yeah, the different.
um, so
So you think it's just the
I guess it's
V?
categorical, right? I mean, it depends how they're going to weigh them. It was by weight. Would it by weight be quantitative?
Yeah, it would actually.
But it doesn't necessarily say that either, so.
You're right. It probably is quantitative, so it's not going to
It
be
says
E.
measure the amount, but it doesn't necessarily say how they're going to measure it. But would that be, if it was quantitative, would it be a one sample T? Because it would be the difference between the two?
I'm gonna say yeah. I'm gonna put B.
V, the one sample.
I had a hard time with that one.
Yeah, it's kind of hard to figure out which category it goes under.
Yeah.
Is that what you think, Steph, is B?
I'm just trying to think it through. So if it's quantitative, then it would either be A, B, or C,
Yeah.
or D. And then if we're comparing the difference, is that kind of what we're comparing? So we're measuring, let's see.
We're not measuring the difference. We're trying to find the
Is it something about filling?
average. They're trying to find the mean, the average,
The average filling.
comparing it to what the company says the average is.
Well, yeah, they're comparing it to a regular Oreo to see if it's truly
The double stuff and the double stuff Oreo compared to a regular.
Would it be a? Oh gosh.
So see, I think that could. I would even say
My mind thinks,
independent.
is it paired because then we have the single Oreo that they're comparing it to?
They're not comparing it to a single Oreo. They're comparing it to what the company says the average is. So they're taking all those cookies and finding out what the average.
Well, it says
Wait.
double stuff are supposed to have twice the filling of regular, and you want to know if that's really true.
Uh-huh.
So I don't think, so the company's saying, well, I mean, I think they're just comparing it because there's a double stuff and then there's just a regular Oreo. And they want to measure the amount of the
Actually, maybe it's D.
See, I was thinking, that's the one I was thinking, is the independent sample.
Independent?
Gonna change it to D.
But I don't know though, I mean, because they're not dependent on each other. The double stuff's not dependent on the single.
Mm.
And so their numbers are going to be different.
Trying to figure out how that single Oreo plays into. I know what they're doing. I'm just trying to figure it out in my brain. How that plays into the equation. With independent samples, you're comparing two things, right? That are not dependent on each other.
Yeah, so wouldn't you be comparing the single Oreos to the double stuffed Oreos? And they're not dependent on each other. I don't think the double stuff is dependent on the single. And the single is not dependent on the Oreo, on the double stuff.
Right. So when we have the data, we'd have to know what the single Oreos are, right? At least what the averages of that to know what
Correct.
the difference of the double stuff. That kind of seems to fit the bill. Okay. So, number 9.
Did you think it was the independent one on 8?
On 8? Yeah, that's what I put.
Okay, and after we can come back to these two. All right, 9. I'm probably totally off on that. I thought it was the probability of the type 1 error.
Yeah, I did too.
I put that's the one I put.
Sorry, which one did you put?
I put, well, the probability of the type 1 error.
Okay. I was just going to double check that because I know that there's something about sample statistics and stuff. This was, though, for the notion. Level of a hypothesis test. I think that's in our recaps.
Yeah, I read that in the book. I read it somewhere. It says something about.
Okay.
I know I read something about the probability of the type 1 error. That's why I put that there.
The level of significance is the standard for determining whether or not the null hypothesis should be rejected. Is that the same what it's asking?
Which one is fine? Best defines the notion of the significance of the hypothesis. When I first read it, I thought, is it the probability of rejecting the null hypothesis, whether it's true or not? But I don't think that's what I don't know if that's what the notion is or if that's what. Probability of rejecting the null, whether it's true or not.
Quickly flip through the chapter. Previous chapters. I think I'm on the wrong one. Not in my lesson recaps.
Yeah, I know I read in there somewhere where it said something about the type 1 error. That's why I put it there.
No, and I'm trying to just Google it, or not Google it, search it in the book. Significance level, right? Level of significance. Well, we need a way to determine if there's enough evidence to reject the null. Yeah.
See, it doesn't, and I don't think the thing, I don't think it determines whether the null is true or not.
Just if there's significant rejection. The level of significance is the standard for determining whether or not the null hypothesis should be rejected. Is that what that one? Okay. So was it A then?
See, that's the one, when I first did this, I put A, but then I was just going through and I swear I saw something that said the probability of a type 1 error, but I mean, is it the probability of rejecting the null?
Well,
or is the probability of rejecting the null?
In lesson 9,
Uh-huh.
On 4.4 it says it, but also down in the summary it says blah blah blah. Let's see. The level of significance is the standard for determining whether or not the null hypothesis should be rejected.
Okay. See, and I don't know why I changed that, because that's when I first did this.
So
that's
levels
when I had
of
marked.
significance is alpha, and
Right.
alpha is what is it called? Opposite. I can't remember the actual mathematical term for it. Of p-value. Because it says specifically if p-value is greater than alpha, then null. So I know one of them is the type. I feel like one is type 1 error and one is type 2 error. And I think alpha is type 1 error, and p-value, I was thinking the second one for p-value.
Yeah, for the p-value, I had the second one marked on that. For 10, I had the probability of observing a sample statistic more extreme than the one actually obtained. The null hypothesis true. Is that what you have for 10?
And then I have probability of a type 1 error for 9.
Yeah, when I first did it, I thought it was the probability of rejecting the null, whether it's true or not. And then for some reason, I thought I read somewhere that said it's the type 1 error, but it sounded like Stephanie just read where it says it's the probability of.
I know, sometimes you read it and it just depends on what it's applying to.
Well, okay, so you do a Google search for level of significance, and a portion of a Wikipedia page pops up and it says the null hypothesis is rejected if the p-value is less than the significance of alpha level. The alpha level is the probability of rejecting the null hypothesis given that it is true. In parentheses, it says type 1 error. So level of, or alpha is the probability of type 1 error.
And I think I remember that somewhere too. I just wanted to confirm that against this other definition that's given in our book.
Makes sense. I did try to find that a few days ago in the book because I remember reading it, but I couldn't find it.
And I remember somewhere on hypotheses and null hypotheses. I'm just trying to remember the lesson it was on. Oh, type 1 and type 2 errors. Let's compare this. That's also in lesson 9.
Oh, I'm terrible.
Okay, so here it says again, and when it's talking about type 1 and type 2 errors, so it says the level of significance is the probability of getting a value of the statistic that is extreme enough that the null hypothesis will be rejected. In other words, the level of significance A is the probability of committing a type 1 error. So it kind of sounds like it's both, but I'm assuming the wording in that question is probably not exactly right on B. So
Yeah.
it must be a wording thing. I'm just trying to compare it. Okay, well, good. We can go on to the next one then.
What did you get? Did you get the type 1 error then?
I'm actually just still rereading it to make it make sense in my brain.
It's awesome. No,
But you can
that's
go on
good.
to the next one. If you're
No.
I just have to have it make sense to me.
No, heck no. Trust me, I'm not ready for this test tomorrow. Are you ready for it, Emma?
No, not really.
I don't really like how it's on a Wednesday. I wonder if she let us. I wonder if she did it just because she didn't want us to have to take it on the 4th.
Wait, I didn't even notice that.
Yeah, it's tomorrow.
Yeah,
I'd rather take it on the 4th.
Yeah, I would too.
I'm going to email her right
emailed
now and tell her that I'm going to be traveling tomorrow.
Just say our whole group needs to be extended to Saturday.
Do it. I actually emailed her. Staff email. I emailed her.
So I would much rather.
I wonder if she gets enough saying that people didn't realize how soon it was that she'll do it.
Yeah, I'd rather take it on Saturday because I'd rather study for it more.
Uh-huh.
Oh my gosh, it is so hot. All right.
Okay, so I'm going to read this definition again from the book.
Hey.
Somebody read it from the test and tell me, because I feel like it's saying both of them is the same.
Okay, do you want me to read what the question says or what the answer that we think says?
Well, read answer B and let me compare it to what it's saying in the test. So, anyway, yeah, go ahead.
Okay, you want me to go first?
Yes.
Okay, this says, do you want me to read the second one?
The second one.
The probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
Okay, so it's twisted a little. So then it's A.
Yeah.
Because in the book it says A is the probability of getting a value of the test statistic that is extreme enough that the null hypothesis will be rejected.
And this one's saying assuming the null hypothesis is true.
So it's twisting it just enough, right? So that it's not that one.
Yeah, I don't think it's that one.
Because then it says, in other words, the level of significance is the probability of committing a type 1 error.
Yeah.
So that second one has similar wording, but not exactly compared to the definition in the textbook. Okay. All right, that makes me understand it better. All right, and so we did the next one on p-value.
What is it? What are you going with on 9?
I don't know. Hang on. I thought we did that one. But there is, okay, so let me read the definition on chapter 9 here.
Okay.
The p-value is the probability of getting a test statistic at least as extreme as the one you got, assuming null is true.
This one says more extreme.
And this one says
Didn't it say almost extreme or almost as
No, it
extreme?
does say more extreme.
Yeah, this one says the
No,
probability,
at least as extreme as the one we got.
and this one says more extreme. So I think that will.
So then,
Oh, dude. Oh,
Which one are you guys on again?
the p-value.
oh. Well, this, yeah, the p-value.
The p-value. I think that it's probably the second one.
Yeah, so Steph, that one you were reading, that was for the p-value, right? The one that says just as extreme?
This is as extreme, yeah.
And this one says more extreme, but I think that one's, I still think 10 is B still. That defines the p-value. Right there.
Yeah, that's why I was leaning towards that second one because.
I think so. I think it's that one. I think it is the second one.
Okay.
Yeah, I'm going to mark B because I think that's what it is. All right, moving on. And before we submit them, we can come back and look at them too.
Yeah. If we stumble upon something else,
Yeah.
maybe
All right.
find another answer. Okay. So.
Hey, I'm never going to discount 11. Okay, you got to be quiet.
11. I got C for 11.
And that's what I put also.
Something we are 95% sure that means we have a 95% chance. Between 10 and 20. Yeah, C. Sample means not present. That is not the same chance between. Yeah. Yeah, I think C too.
It's not B, right? It's the true
No.
mean. That's the difference on that. It's the true mean.
Mm-hmm. True mean, yep. Not the sample mean, but it's the true mean, yep.
Right.
All right, we ready for 12?
Yeah, and that's about as far as I've gotten on some of these. I have a couple others listed further down.
All right.
Okay.
12. I thought this one gave us the mean.
12, I think it was D.
I had .30, yeah, that's what I had too.
The mean distribution, there's a formula for that, right?
Well, it gives it to us right there.
Well,
in P.
if the sample size is large enough, then the sample mean is equal to the true mean. And they give
Yeah.
us the true mean. So I think it's just the same thing.
Yeah. That's what I think, the same thing too. I guess I had B. And I know the sample is definitely large enough, so
displayed like how familiar I am with him in the original chapter, and then 3 chapters later, I just don't feel familiar with him.
A lot of information.
The mean of the distribution.
Sorry, I've been so quiet. I've been trying to work on the future answers while.
Oh, that's okay. That's all right. I've answered 15, 16.
Well, isn't the formula, isn't it m equals
It has a good sample size. It's 100. Or have we gone on to 30 or 13?
No, it's still 12. I just know there's a formula for it, so I just wanted to see it.
Oh, the formula is just with a big enough sample size, the true mean equals the sample mean. It's x bar equals mu. That's the formula.
So what? I'm trying to think what chapter this would be.
So on 13, what is the standard deviation of the distribution of the sample proportions? These are like all back in the first few chapters.
Yeah. Did you do 12 or did you just skip it?
Well, I was kind of just watching for a formula.
Okay.
So I have a kid that's texting me instead of his dad.
You had a kid that's texting you?
Yeah, he's just funny.
Yeah, I know the standard deviation. I know that one. And that's back in like.
I couldn't remember how to get 13.
When you get 13, yeah, there's a formula. We just need the standard deviation formula, right?
Yep.
Uh-huh.
Mm-hmm. It's where you have
Standard deviation is sigma equals the square root of sigma squared. What?
So let's see, the sigma equals the square root of 1 over n minus 1 e x minus x bar squared. Is there something that I can just like input it into the numbers into?
I tried to do that too. I tried to put in all the different spreadsheets and I couldn't make it work. What is the standard deviation?
doing a search for sigma calculator.
And they've got them on there. Where did I? Are you calculating 13 right now, Steph?
Yeah, I was just trying to find what the formula is for the standard deviation.
Yeah, and I swear I have that right here.
Standard deviation is sigma, right?
What's that?
Yeah, the standard deviation is sigma, right?
I thought it was. Where's-
I am not finding a good calculator. I kind of want to guess it's the second one.
Standard deviation. It's gotta be somewhere. Oh, gosh.
Standard deviation.
Standard deviation of x is sigma divided by square root of the sample size. Did you find the formula?
Well, there's one formula for standard deviation, but it's really long. But I know there used to be something like with the N and the P.
Yeah.
I mean, otherwise you take, the mean and the median and subtract them and all this stuff.
Yeah.
But we don't have that information to do that.
How do I get this one? What is a standard deviation? this isn't not this because this one is just to get like the confidence intervals. That one's a little bit longer, but just to get the standard deviation, I thought that was a little. Assume the unknown population portion. So then we just have to do that where the sigma is not. Okay, and delta is not.
Dang, this has to be submitted tonight, huh?
Yeah.
I think this is the longest.
This one is. It's 39 questions.
Yeah.
But I think once we get rolling, we'll be doing good. It's just. I found this 13. What did I do? Have you? I got 0.4 or 0.046. And I had it in a calculator because I had a formula for it. Where is that?
I put 0.046, but that's just because it seems the most logical. I don't even know what.
Well, I calculated it somehow, and I'm trying to remember.
I feel like it's too long to calculate.
Yeah, it's not. Well, you don't. It's just like for the standard deviation. It's just a small formula. It's like we have to take the p, which is 0.30, minus that. Or it's like 1 minus 0.3, and divide that by something.
Well, I thought the standard deviation was that big old long one that you had to sum everything out. It has the sum, the big E in the formula.
I thought it was a smaller one. Let's see. Standard.
And I think it's kind of ridiculous that they're asking us to do that for a 101.
First, look at the average. Okay. Yeah. So I think mu is just equals 1 divided 1 divided by the sample size squared.
Is sample proportions p hot?
I know that's something. Sample proportion.
I don't think so.
When your data is the whole population, the population standard is where's hey, I'm gonna screenshot this thing right here. Just tell me if this is what it looks like. Because it makes sense to me, but this isn't it this formula right here?
Yes.
Yeah, but how do we do that?
I don't think just get rid of that the little stupid E thing right there.
The
So I
E
think
is sum of. You can't get rid of it.
Well, okay, let's see. I never.
I wrote it down in my notes as that.
Where are they getting the 1 from? Important.
One? What one? Oh,
See how
the
it says 1 divided by n? Oh, wait a minute. Oh, okay, it's going back. It's going
And
back.
the one is just to balance things, balance the equation.
You take let's just put this right here. Thirty. 30 minus 1.
What?
And divided by 6. 0.04. Oh, I figured it out.
Ooh, how'd you figure it out? Do tell.
Well, at least I got the 0.046 answer again. Got that again. I don't know if it's right. I just took the square root and then I put 0.3, which is the sample, whatever, the mean. And I put 0.3 and I times that in parentheses, the 0.3 minus 1, and then I divided that by 100, which is the sample size. And I swear that's the formula. And I got 0.0458, and you round to 3, so it's 0.046. See, but then it also could be 0.458 because 0.0458 7.3. Steph, I can see you working hard over there.
I can. Look at the summary on chapter 16.
The summary?
The summary on chapter 16.
I'm going to go and look at the summary on chapter 16.
Lesson 16.
Let's see, lesson.
The summary, is that at the very end?
Yeah.
Very end. Yeah, it's just a tan box, an orange box.
Is it the p times 1 minus p divided by n, that one?
Yeah, see how it says the sampling distribution of P has a mean of
Hey, so then I have the right...
deviation of, so that's the formula.
Hey, that's the formula that I used.
Yay!
And the P hat is what it says in the question, P hat is the sample proportion.
Sample proportion, yeah.
Population, but P is the population proportion, P hat is the sample proportion.
Okay.
Okay, so now I was just going to figure it because I was kind of on this track here and I wasn't listening. Sorry.
No, you're good. No, you're good. You found the thing.
Is
That's
that the same
good.
formula you used?
It is the same one I used, but tell me if you get the same answer.
And it's the square root of that, right?
Yep. So our P, that's 0.3, right?
P is 0.3, yeah.
Yep, so I had 0.3, and then you times that in 0.3 minus, I had it backwards. I had 0.3 minus 1, so I'll just put 1 minus.
It is. Okay, I got 0.00458.
0.0?
I got 2 zeros after the decimal.
Okay, I just got 1.
Let me refigure this.
Well, no, I might have done it wrong. 0.00. Is there an answer, 0.00?
Well, there's a 0.004.
Yeah, see, which one? Oh, I see what you're saying. I think it's 0.458.
Okay, so it just depends on what do you call it? Oh my gosh, I'm so tired. The the parentheses and all that. What's that called?
Oh, order of operation?
Order of operations. There we go. Because I get 0.458 on one, and I get anyway. So when I do
Try doing this.
when I do the whole number and I just take the answer and then do the square root of the answer, then I get the 0.004. But I'm not 100% sure that the way my calculator is setting up square roots the whole thing. So that's, anyway. So it's just a difference of how I do my order of operations and get both answers.
Now you just get to pick which answer you want.
I can just pick the one I want?
Yeah.
Okay.
How it should be.
Will you
Emma, did you?
I keep getting 0.046.
Yeah, that's what I got. 0.04. Well, I think if you round it, 0.0458. Because you go to the third, right? So I thought. Let me see. Let me look at the answer.
I keep getting the second one, so I'm gonna stick with the second one there.
0.046. That's what I first had, but I thought you went to the 8.
I just can't get my thing to square root like the whole formula. I feel like it square roots the beginning part of it and then it divides that by 100.
So
Can you put parentheses on your thing?
I just did it systematically. How I remember the order of operations is pepperoni pizza makes dog sack silly. Powers parentheses. Pepperoni pizza. Multiplication. Addition, division.
So how I got the 0.0458, I just square root and then I put 0.3, or actually I put square root and I put parentheses. And then I put 0.30. Oh, go ahead.
I did it step by step in my calculator. So I did the 1 minus 0.3 and then times that by 0.3, then divided that by 100, and then I square rooted that.
Oh.
I'm just trying to figure out. So, because I feel like when I put it in the calculator, it's not. I'm not confident that it's square rooting the whole problem. So then I did the formula and then I square rooted the answer. So I get them different ways. Ooh. And I'm using 2 different kind of calculators. Oh my goodness gracious. And I don't really get 0.4. So which one is it? It's got to be the 0.458. 0.0458, right?
That's what I got. But you only go 3 decimals. Or 0.0458.
I just got an email back from Sister Cook saying she won't extend the date.
She will not extend the date?
She says she sent out an email. This one she says no, that the exam 2 opened, but I think she meant exam 3. Opened up on Monday the 29th at 12 and will close on Wednesday, July 1st at 12. All of the statistics classes are organized this way. They want All of the statistics classes begin at the exam at the same time, so I will not be extending the date. The only time that I will allow extension is for health reasons or a death.
I hate this. I really hate this class.
What?
I really hate this class.
I know. I would have liked the extension, but
I
I
went to
could
Boise
have seen, you know, it's the date's been there for a while, so I could have very well seen her saying, you know, I should have looked at the date and planned accordingly. Which doesn't help me out any because I didn't do that, but.
Ah.
Hey Josh, so what calculator are you using?
Do you have like an Android phone?
Yeah, and I'm doing the Math Lab.
Oh, you downloaded that?
I did.
Okay, go to here. We'll do it. Okay, go to so just do square root.
Right.
And then do the parenthesis. And then do 0.30. And then do the same kind of parenthesis. And then do 1 minus 0.3 or 0.30.
Right.
And then I did an end parenthesis. And then divide. And then do parentheses around 100.
Parentheses around 100?
Yeah, so you'll do divide, and then you'll do open parenthesis 100, then close parenthesis.
And does that make it so... I'm going to reset it up. So you're doing, okay, that's my order of operations then.
Mm-hmm. I could take a screenshot and send it to you.
Does your square root encompass the whole formula?
Yes.
See, that's where I'm having my issue. I just want to make sure that I know how to do this right.
So yeah, your square root, it's covering everything.
Because before mine wasn't, and so that's when I was getting kind of wonky answers. Or, you know, I wasn't sure about them.
I think if you do square root but don't put like the parentheses around the numbers, I don't think it'll go all the way around.
Screenshot it for me so I can just double check it.
I know, I'm trying to. I don't know how do I do that.
I don't know either. So,
I would send you.
So what answer are you getting then? Doing it that
I
way?
got 0.0458257 and then a bunch of other numbers. Is that what you got?
No, I get that answer when I work out the formula inside the square root and then just square root the answer. I get that. Which should be the same.
You're supposed to work it out and then square root the whole thing.
Yeah, it doesn't. I get.
A scientific calculator should be able to do it though.
Yeah, this calculator. Yeah, the calculator. You don't have to. It does the order of operations for you. But So, what answer are you getting when you do? But are you getting the same answer? Or you're just doing it a different way?
No. When I do that, it only square roots the 0.03
Oh, I see what you're
portion
saying.
of it. So then it gives me a totally different answer.
So when you write it, your end answer, does it have the whole square root thing over all your numbers?
No, it doesn't. Even though I put
Let me see.
parentheses.
If I could, I know there's a way to send this to you. I don't know how to. Well, you can see my screen, right? I don't know if I can make it any bigger.
Yeah, I can see.
Okay, look at my. Can you see what that says?
Okay, tip it just a little. I can almost see it. It's glared. Try tipping it.
Let's see. I don't know why. Hey, we turn this light off. Oh. That didn't help.
Why do I do that?
What?
It's off now. Mine's not encompassing that whole thing. I'm gonna have to play around with it and figure it out. But okay.
Oh, there you go. Now look at it.
Yeah.
Yours doesn't go all the way over?
No, it doesn't. But if yours is doing that and that's the same answer, then I feel confident that it's.
Well, let's try. Okay, let's try one more time, just because I want to get to K. So go square root, and then you do the little brackety thing, right?
Oh, you're doing a bracket or a
Are you?
parenthesis?
Oh, are you doing a parenthesis?
Well, I was. I don't know what to do. Is the bracket better?
Oh, okay. Yep. You know, it's right. It's up at the top right, right? You got the little. It's right above the equal sign, right?
Is the parenthesis?
Okay, that's okay. Is that what you were using?
Yeah. So how do you do the bracket?
No, I was using that. That's what I was using, was the thing right above the equal sign. So okay, hit square root and now hit the open bracket.
Oh man, I lost my something.
She lost it.
Oh, shit. Okay. Okay, so square root.
And then do the brackety thing.
And then times, right?
No, don't do anything. And then is it 0.30 or 0.3? I can't remember.
0.30.
Okay, now go 0.30. And you don't have to do times because it'll do it for you.
Right.
And then hit the open-ended bracket. So you should have two brackets that look the exact same. Going the same way. Yeah.
Oh. And
I
then
think
you
that's
divided by?
no. So you hit 0.30 and then now you go, is it 0.30 minus 1 or 1 minus 0.30?
Oh, okay, hang on. I got onto the next. So you do the open-ended bracket, and then you do...
And then you do, is it 1 minus 0.30?
It's 1 minus 0.30.
Or 1 minus, so then you go 1 minus 0.30. And without doing anything to your bracket, does that still give you 0.458?
Yep.
Okay, now do close your bracket.
Well,
and then
yeah, close bracket.
Close bracket, and then do a divide.
Okay.
And then do your open bracket. And then I think it's...
Did it.
Cool.
It was that, it was the difference of that, I was doing a closed bracket after that first point.
Oh, that's why, okay. That's why I was going short. Cool.
Okay. Okay, at least now I know how to set it up. Sorry, Gabby's probably frustrated with me trying to figure out how to use my calculator.
No, that's good.
Okay.
Sorry, I don't know why my dad's calling. I don't know why. Sorry.
Okay, so now what is
Hello?
the probability calculation?
Hey, Dad. Sorry. Okay, bye. Oh, my dad loves me. All right.
Awesome.
That is awesome. Dang it, I'm a little sad that I have to take the test tomorrow. I'm not ready for it. That's all right.
Good thing I got out of the way.
Okay.
Okay. So now the next one, we want to just find the...
What is the probability? And I know this one is an easy one, and I think I just put the 0.862, but I don't think that's right. Because we can just use the numbers we got. Oh, actually, no, I did do this. I did do this because we have all the numbers, and then we can put the thing into the probability thing, and it'll have a some portion less than 0.25. I think I still have it up, don't I?
Oh, okay.
But I know it's figure that out real easy. You just take the yeah, because we already have both the things. We already have the question 12 and then question 13. Oh, so I think we just divide. Yeah, we just divide them.
Uh-huh.
But if
So you
p hat
take-
is 0.30 and p is 0.30, then that's 0.
Well, I think the other one, I think it was different, wasn't it? Wasn't it? Yeah, see, this one's 0.25. So I think we go 0.25 minus 0.30.
Oh, that's right.
30, and that gives us the result.
Less than. Random sample have a sample proportion less than. Yeah.
And so then we get a z-score, or yeah, z-score of negative 1.087. At least that's what I got. Hopefully you guys get it.
How did you get that? So what's the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
You just take the, so you just, I know the formula, I'll go find it, but I know it's, so you take the 0.25 and minus that from 0.30,
It is quite good.
and then you divide that by the standard deviation. And then, and then you
It
square
could be
it.
heated up, but I'm not gonna
And
bother.
then I think you square it. I'm pretty sure you square it, but I can't, let's see. Yeah, I can't remember if you square this one or not. Let me do it and see.
Hi, are you guys still on,
We're on 14.
Oh, I'm 14. Did you do 14?
1 second, I'm looking. I don't know how I got this, but I was thinking that it was 0.876.
I'm trying to think of how I got 0.862 somehow. And I got it because I know for the formula is you take the 0.25 and minus that from your sample size, or the 0.30, and then you divide that by the standard deviation. And I just can't remember is if you square the answer or if you just leave that answer the same, or if you square it. Negative 1.5.
And then you're plugging that number into the probability output.
Mm-hmm. And then I think it said it was less than. So
I'm getting 0.005. Is that what you're doing? Are you doing 0.3 minus 0.25 divided by 100?
mm-hmm. No, you go, no, say that, so say you do the 0.25 minus 0.30, and then you divide that by the standard deviation. So you just divide that by the answer we got in the top number 13, so it's divided by 0.046.
So 0.25 minus 0.30 is negative 0.05.
Uh-huh.
And then you're dividing that
And then you divide that by the
by
standard
100.
deviation, by
By
the
the standard
0.046.
deviation,
Yep.
which was, let's see, 0. So then you get negative 1.0869.
Uh-huh.
And
And then I don't know if you, and I put that into the thing, and then I put the negative 1.0, and then I just rounded to 3, so negative 1.087.
Right. And then we're looking for,
Yeah, the less than, I think. So I think it includes the middle and then the left. I think that's what it is.
less than 2.5.
What did you? So I got
Or you plug,
0.86. What's that?
you're plugging in negative 1.87 into the z-score?
Negative 1.087.
Oh, it helps to add the 0 in
Uh-huh. And then I just took the middle and then the left-hand side because it wanted less than, right?
Yeah, it wanted less than.
there. Right. Right.
So I think that's the middle and the left. So I got 0.862 if you're on the third.
I think,
Actually, just the
isn't
left.
it just the tail?
It is,
Okay, yeah, that's,
because
it
the
might be
z-score
because I always
because the
use
z-score, you have to go by that red line, right?
Uh-huh. Because the number that we got was the negative, so anything below the negative.
Right.
Okay, so that's the, okay, you're right, that's right. So that's
So
the
it's
0.1,
0.139.
0.13 or 0.138.
Yeah.
Oh, it would be 0.139 actually. See, and this one's not rounded up to that.
And maybe that was just an error, for a teacher error.
And I'm pretty sure that's the formula, because I don't think on this, I don't think you have to get the answer and square it. I think that's for something else. So I'm pretty sure it's the 0.138. You think it's that, Steph?
Yeah, I mean, it all seems to work.
Yeah.
I just need all my formulas in front of me. I haven't written them all down again for this test, so. But yeah, that seems to work.
I think that's it. All right, should we go on to 4 and 15?
Yes.
I think these get a little easier now. So for this one, I started using the Excel spreadsheet for these,
Mm-hmm.
Oh, yeah.
I did too.
and I got negative 0.003 and 0.029.
Mm-hmm. That's what I got.
Sweet.
Open the Excel spreadsheet. Right, I just would never find the easy way to open this stinking Excel spreadsheet.
I know. I remember how we were having a hard time last time, and so I had to go and do the, where I went to the, oh god, the lab, the SPSS type thing,
Mm-hmm.
where you go into that, and so that's the fastest way that I found to do it. Oh man.
Okay, so this one was, so we were just inputting the data, right? And it was what kind of test?
Oh, I think it's just the two proportion one, I think. Yeah, it's just the two proportion one. Or, oh yeah, two proportion one. Yeah.
Sorry, I'm still trying to figure out how to open up Excel. Okay, so it was on the quantitative or the qualitative? Or the,
I think it was the qualitative one.
let's see.
Super 6.
Oh yeah, because this is the last one. Wasn't it that chi or whatever where it's no.
Yeah. It's the one that had the yeah. It's that same one.
Where it's like this of this and this of that, right?
Mm-hmm. Yep.
Do this. Oh, but it was on multiple, so it was on the 2 proportion, correct?
The 2 proportion. Yep. The good news is, guys, we're almost halfway done.
Oh, good.
Yep.
I think these just will go quicker. Let me see.
Oh, I think they will too.
Okay, and then what were we looking for?
It's just the confidence interval, 95%.
95%. Negative 0.003 and 0.029.
That's what we
Awesome.
got.
Okay, and then the
Good.
next one. I have the next one. I put B or number 2.
Which one?
Number 2.
On 16?
Okay.
The no P1 equals P2 and the alternative
I
is
got
P1
the
is
second
equal
one too.
I got the second one, yep.
Because it's just asking if there's a difference.
Yep. I wish they could all be like that.
And then the test statistic is the Z,
Yep.
the 1.458.
That's what I got.
The p-value, I have 0.928. That's not an option.
Huh? P-value, did you make sure that it's
Switch your test. Switch the
not
type
equal
of.
to?
Oh, yeah, that's right. It's the test. Type of test is not greater than, but not equal. And there it changes it to 0.145.
Woohoo!
Okay, we're cruising. So for
Then
p-value,
I put 1, 2, 3, 4, 5. I put the 5th one for 19.
That's what I put too. I put the 5th one.
right. No, I failed to reject the no.
Uh-huh.
Yep. That's it.
All right.
Yeah, we're in 20. We're cruising now. And this one, I just entered those numbers into the Chi test, or whatever it is.
Hi.
For 20, did you get the 6.580, Emma?
26.580. Mm-hmm.
Okay. Okay, that's. I think I still have this pulled up from when I did it earlier. Oh no, this is the second.
So what are we asking? The test statistic?
The test statistic, yep.
6.58.
Yep, 6.580 would work.
And then p-value is 0.87.
I told you I was going to do the bathroom, but you kind of did. You kind of did that, and you were supposed to. Okay, you didn't. Okay, you didn't. She cleaned it. She was in there. Okay, okay. I will. Okay, let's see. I will talk to you after I get done with this. Okay. I will talk to you when I get done. You said you were gonna hang those up. You're not going to bed. Okay, you're not going to bed until you hang them up. Okay, you're not going to bed until you hang those up. Oh, what did you get for 21?
21, I got 0.087.
0.087, yes.
Is that you got, Steph? Sweet.
That's what I got.
All right, 22.
So I have no, the p-value is greater than 0.05.
That's what I had too.
That's what I have.
Okay,
Sweet.
so what would we conclude?
23.
We have insufficient evidence.
I wasn't positive about this one, but we have insufficient evidence to say that being a morning or an evening person is not independent on age.
I have B marked, but I'm not sure if it's
Man, I gotta look at these. These are tricky the way they're worded.
They are so weirdly worded.
They're almost opposite of the other.
Yeah.
I feel like.
Well, we know that we failed to reject the null.
Failed to reject. So if we fail to reject, that means we have sufficient or insufficient.
Yeah, and the null is being a morning person or an evening person is independent of age.
So if we reject it.
We failed to reject that notion.
Oh, so yeah, probably is C then. We have insufficient evidence to say that being a morning or evening person is not independent on age.
We did not reject the null. Did you have C? Like the third one?
Yeah.
Yeah.
Okay.
Is that the one you think it is?
Uh-huh.
Yeah, I think it's C. All right, 24.
I got the fourth one for 24.
1, 2, 3, that's what I got.
0.028.
And then that's what I got too.
And so.
Did you put it into the little calculator thing?
Yeah, the categorical data analysis hat.
Categorical data analysis hat.
And that's the last one I've worked on.
Okay.
I haven't.
Hang on. Which
One
did you
proportion?
use?
I used one proportion.
The one sample Z test?
No, one proportion. Oh, one
Yeah,
sample
so,
Z
yeah,
test
one
for
sample.
a proportion. So I didn't change the null hypothesis
I didn't change it either.
or the confidence interval. And for number I put 200, and for x I put 40 because that is 20% of 200.
So on 25, can we, let's see, how do we, shoot, that's a formula, isn't it?
Did you get 24, Steph?
Oh, yeah, so 0.190. And
Uh-uh.
0.30?
Oh, we got zero. I got 0.028.
Okay, hang on. So you didn't change. You left it at 95% confidence.
Uh-huh.
Because it's based on 95, so you gotta leave that.
And we're trying to figure out. What are we trying to get? Let me see that.
So I put in
I'll be right
200 for the number, and then for X I put 40 because that's 20%
But it was
of.
50. It says 50 of these outperformed. So hang on. Maybe I got my numbers wrong.
It says 20% of all investment managers outperformed the Dow Jones Industrial Average.
So that's your null hypothesis. That the numbers they're giving you is 200 and 50, 200, and then 50 out of that 200 outperformed.
Okay, so the null hypothesis is 40? Wait. Oh, the null hypothesis is 0.2. And X is 50.
Uh-huh.
Okay, so then that's the first one. Okay.
The null hypothesis, that's right. The null hypothesis is the 0.20, right?
Uh-huh.
Okay, that didn't change my confidence level. Oh, no? It still didn't change my confidence level. Because it didn't go in right. Here we go.
Okay, I changed the numbers and I have A. 1.95, comma.
So you've got X is 50, N is 100. Or sorry, 200.
Yeah, X is. Oh, X should be 100.
Why is that?
50%.
No, it said 50 of these. It doesn't say 50%.
Oh, right. So I was right. Okay. Yeah, X is 50, N is 200, confidence level is 0.95, and null hypothesis is 0.2.
And then I get 0.19 and 0.310.
So confidence, I got 0.110 and 0.310.
Yeah.
Okay.
That's what I got.
That's
Okay.
good job, Steph.
Okay,
Because
so
I had the fourth one though.
Yeah, I originally had the fourth one.
Okay.
All right.
unless it's the last one, which I'm not even sure how that plays into it.
I don't think it's the
I'm
last
just
one.
kidding. I'm playing with my brain. Okay, suppose you've been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with 95%? Oh, I hate these. There's a formula for this, isn't there? Or can we just
I think that the formula in the summary of lesson 17.
We'll say scriptures.
17? Okay, for the margin of error.
Uh-huh.
Yeah, that's it. We can determine the sample size we need. That's right. N equals
Apparently it's broke. Okay, I'll go. Just let me do this now. Max, he's alright. Max, just don't. Max. Just relax. Oh. Holy crap. 10 minutes. Please, Lex, just stay. Don't get back. Just stay here. I'm sorry. So on the 25, I got 2401, but I don't know if I do that.
I'm still calculating.
All right.
Do you have the Z-score? Or no, the margin of error.
The
Z-score is
2%.
confidence level.
Yeah, the 2% is the margin of error. With 95, yeah, I put that in the formula. I put that.
Margin of error is 2%. So on that, you're doing 0.002, right?
For the margin of error,
Mm-hmm.
I just put in 2. Oh, but you're supposed to do the 0.002, huh?
Mm-hmm.
Yeah, that's right. I still got the same answer, but when I got it, it said like 0.2401. So that's why. So you guys is 2.
I'm doing something wrong.
And
I
this,
got 1,082.
1082.
Yeah.
How did I get this?
I don't know. Let's see. Margin error is 2%.
So margin of error is 2%. You know, does anybody know the exact formula for this one?
Isn't the formula the thing in the summary of lesson 17? N equals the
It probably is.
Z percentage number thingy divided by M squared times P thing
Uh-huh.
times.
Oh, the Z squared. Oh, yeah. I knew there was a square somewhere. So when it says Z squared, is that where we put our 1.96?
The Z is our 1.96.
Okay. Well,
Oh, that's my problem. I did the wrong Z. I thought that it was 1.645.
then you divide that by the M. Is the M the point estimate? I can't remember.
Wait, I thought it is.
For 95%, it's 1.96.
Yes. But you can do it in the. You can find it out in the probability applet by putting
just put it
0.95
in.
in the area.
Oh,
When
yeah.
I put 95 in the area, the Z-score is 1.645.
Yeah, I know it's 1.96 because it says it even in the it says it in this chapter somewhere. There's a thing. Oh, it's on 3.1. Just go to 3.1 example.
3.1 example?
3.1 example when it says it.
Right.
In what lesson?
17.
17, yeah.
3.1 example. Okay. 1.96.
Divide that by 0.03. Ours is what, 0.2? When we divide the 1.96, we divide that by 0.03, right? Or I mean 0.02?
Sorry,
Or is it just 0? On the when we're putting it in that formula, it's the 1.96 divided by m.
Which is 0.02.
Okay. I already did this. You guys, hopefully you guys get the same. Did you get the answer yet?
1 second.
No, because I'm having issues with my operation of these.
Come on, Steph. We just went over the order of operations.
No, but when I try to square that one, order of operations, yes.
All right, I got 16.
Ah, crap. I got 2401.
Oh,
But I might have done it.
What are our P numbers that we're plugging in?
the P number is 0.2.
Divided by 0.02.
Okay.
Here, I'll do it again, but I'm pretty sure that it is in fact 16.
You're probably right. So then I got 9604. I got 96. So I got 9604. 0.82 and ours is 0.2. 0.2. 1.2.
Yeah, I got.
On this one I got, and then on this one I got 1537.
That's what I got. But you have to round it up because it's a whole number.
Yeah, so, well, it's like 1536.64, but you round that up, so 1537.
I got 15.68, which I just rounded up to 16.
Oh, I actually got 1536.64. So you'd round up to 1537, which is crappy because that's an answer.
You have to round to a whole number.
Dude, I know I am. It's 1536.64, so the whole number would be 1537, which is number 2. N equals 1537.
I keep getting 15.68.
All right, I'm gonna try this again. So let's do the numbers. So we got 1. Okay, so 1.96 divide our 0.03, but ours is 0.02, right? By 0.02.
See, I get 1537.
That's what I got too. I got 1537 too. 98, and you square that, you get 9604. And then I'm just doing the exact same thing they're doing. 9604. Parentheses 0.82, but ours is 0.2. Parentheses 1 minus 0.2.
Oh, I see what I did wrong.
You know, it's just so simple when you just put something off.
I see what I did wrong.
What did
You
you
guys
do
are
wrong?
right. It is the second one. I forgot to square.
Nice. Alright. 26.
So I got
26, I thought it was the third one. Just because I know that's the formula, but I don't know if that's...
I only got the third one when I forgot to square.
No, I mean on 26.
Oh, 26. Okay.
I mean, oh, what number are we on? Oh, we're on 26, yeah.
Let's see. Yeah, I think it's the third one.
No P equals 0, 2.
This one's better, so it would be greater than.
It would be greater than. So it's the third one. Is that what you got, Steph?
Yep.
Alright. 27. 27, I got the third one.
Yes.
Just because I know that's the formula we use.
Yep, normal distribution.
Did you get that one, Emma?
Yes.
All right, guys, we have 11 more. How cool are we? And now on 28. We have not done this one yet.
What?
No, right?
I am confused.
What's the matter?
Oh, I see. So
I
it's
know we
the
can just
first one.
plug this.
It's the
It's
first
which
one.
one?
The first one, 1.768.
Where are you getting that from? Where are we
Yeah, how do you
going?
get
We're going back to the categorical data analysis, proportion 1.
That deviated a little for a few questions, huh?
How the heck did you know that one? Oh, yeah, because it says we're using bro. And then our p-value is 0.039. Right?
Oh,
Yes.
24,330, so we're still doing, yeah. Okay. And then the p-value,
Oh, God.
0.039. So there's not sufficient, if the p is low, reject the null.
P is low, which it is low. So wouldn't it be yes, I rejected the null? Wouldn't it be the first one?
Yes.
We're trying to see that
If the P is low, rejected the null, which we did. Well, this is a crazy question. Steph, what is your brain telling you? Is there sufficient evidence? So wouldn't it be yes, I accepted the alternative?
we say yes because I rejected the null, right? Is it the first one?
Yeah, and so, yeah, because it's, is there sufficient evidence?
So to say there is sufficient evidence to blah, 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 and therefore you would reject the null. If there's sufficient evidence, yes.
So I think it's 3. Or C.
But,
Hold it, what?
Wouldn't it be the third yes?
I think it's the first one. Yes, I rejected. Well, maybe it is. I don't know.
I think they're saying the same things. It's a matter of how we're supposed to word it.
They are, they yes, because it's just, I think it's in the question, is there sufficient evidence to conclude that graduates from the top 10 business programs have done better?
Okay.
Isn't A and C saying the same thing?
A and C are saying the same thing.
Which one is it?
Essentially, yes, but
Yeah, I mean, yeah.
not technically. They're not technically saying the same thing, but essentially they are. I'm going to put the third one. All right. Oh, goody. Look at all that reading we have to do for the next question.
Steph, what did you put for that one?
This just reminds me of nursing boards where it's like, it's the same answer, but which one's the better answer? So. Because you either reject, you fail to reject the null. You don't accept we never say I accept the alternative.
Yeah.
That's what my thinking is. It's always you accept the null or you fail to reject the null.
So it's probably the first one.
That's what my thinking is on that. That's all.
Yeah. Bye. Just a minute, buddy. What's the time? Just a minute, buddy.
Yeah.
9 more questions, buddy. Ooh, we get a download stuff. Is this?
Uh-huh.
Oh, this is for SPSS, huh? Or can we do it in?
It depends on what we're comparing.
We don't have to do it in SPSS.
You can do this in the other one?
Yeah, you can do them all in it. It's just which one you're familiar with.
So how do we get all this information into the Excel one?
We've had this question before.
We've had this one?
I think so.
Yeah, we have. I can't remember where, but I remember reading that very thing. I remember downloading this file too. I just can't remember.
Stupid blue stuff. Are you doing this in Excel stuff? I mean in SPSS?
Well, I'm more familiar with SPSS of it. I was just going to see which one opened better.
Here we go.
Well, I tried to do an SPSS, but I probably got different numbers than.
Let's see, which test do we run on it again?
Let's see. I thought it said something about comparing scores. Or maybe that's on another question. To compare.
There's just one thing there. We're not
Yeah.
comparing anything.
Yeah, it's the next one down here. Each of which contain treatment substances and used for insurance activity. The boosters are created to the higher blocks. Do you want to use this data to see which has a
So, is this one sample t-test?
That's what I would think it would be. I think that's what I did when I ran it the first time. Was a one sample t-test. But I get the tests mixed up.
Yeah. But it seems quantitative and it only has one set of values.
Mm-hmm.
Yeah.
Was it a Z?
Confidence interval, I got 0.282 and 0.293.
Which test did you end up using?
One sample T.
So you got for the confidence level 0.282 and the upper 0.293?
Yes.
0.282 and 0.293. Is that what you got?
Can we get the answers back on these?
These ones, yes. For the quiz, we don't.
Right, but
Hey, sorry.
Can you get it immediately back on these?
Yes.
Oh, yeah. So what did you guys get again?
I got .282 and .293. And then for the next question, for the degrees of freedom, I got 99.
Okay.
And then for the test statistic, I got a very ugly big number. Well, would you call that big or small? It's negative, but it's big.
What number did you? Because I got a negative number too.
I got negative 13683.938.
Sorry, which was that? What was that number for?
That was a
Oh wait.
test.
Oh wait, I did the wrong one though. This is not equal to, it's not greater than. Not equal to. Oh, that only changes the p-value though. I got negative 13683.938.
Hang on, what was your test statistic? Was it the 109.091? The 109?
That was my test statistic.
For that negative 13683.938.
You got what, Josh?
Yeah, I haven't. I'm still trying to load this stupid thing up. Well, for my degrees of freedom, I got 99. Is that what you got?
Yeah.
And then I haven't done the test statistic.
Oh, I didn't change the null though.
Steph, what did you get?
For what's that?
Your test statistic.
I didn't change the null, so I just changed the null and I got a different number.
What'd you get now?
I got negative 2.803.
Steph, what did you get?
For what?
The test statistic.
Well, I have 109, and that's in SPSS. But I'm just trying to figure it out really quick because what program are you using, Emma?
I'm using the Excel.
For which one?
What do you mean for which one?
Because the others, there's for the qualitative or the quantitative versus categorical. Isn't there?
Yeah, there's like three we can download.
I'm using Excel, the one sample t-test.
Those are for categorical data.
Yeah, there's different.
No, one sample t-test is for quantitative. This is the quantitative test. I am 100% positive on that.
And I'm not as familiar with the Excel because I used SPSS on the others, but
I haven't used this for several weeks because it's the quantitative.
When I open the Excel, on the blue scores on the Excel, I mean, it just doesn't give me any options to show me what test is being used.
You have to copy and paste it into the right Excel.
Yeah.
There's another Excel spreadsheet called Quantitative Inference Processes.
Oh, yeah, yeah.
Yeah, do that one. That's the one I'm on now.
You're doing that?
Yeah, I just down. It says quantitative descriptive statistics.
Quantitative Inference Processes. And so I pasted all of the numbers into that, and I changed the null hypothesis to 0.295, and for the t I got negative 2.803.
Try and pull it up that way. Let me see if I can figure out where to pull that up.
So when you copy and paste the stuff in there, you just like where what stuff you copy and paste it?
You have to download the blue scores file.
Okay. Oh, and then you just copy and paste that into there.
Uh-huh.
I think if I can use this, I'll try to use this over the SPSS. This thing's a little bit easier.
Yeah, I always use the Excel.
Maybe though, I don't know. I use the
Excel really is simpler. It's just copying and pasting. You don't need to know anything.
Steph knows how to use the SPSS really good.
quantitative versus the... So which one do you use, the quantitative descriptive statistics or the quantitative inference procedures?
Quantitative inference procedures.
Inference procedures. Okay, and then you.
The other one has like the Q chart and stuff like that on it.
Oh, okay. Did I paste it in somehow? Oh my god, what did I do? I need to play around with this. So you did the one sample T?
Yes.
I'm not sure how to get all this data in here.
You just copy and paste.
Yeah, I don't see even where to copy and paste it. So like in column A it says variable. Is that where?
Yeah. So in the blue scores file, you just copy all that data.
Right.
So Control Z, and then I just, in the quantitative inference procedures, I highlight A5, the cell, just do Control V.
Oh, hang on. So you have to, okay. Oh, you highlight what? A5, and then what?
Okay, so first I go to the blue scores
Yeah, I got all that.
table, and I highlight all the data, and I do Control C. And then after I have that highlighted and copied, then I go over to the quantitative inference procedures, and I'll go to cell A5, highlight that cell, and do Control V.
That's the nice thing about, that's the difference on SPSS that I liked, is when you just click the Excel sheet under SPSS, it just brings it, takes in all the data to it. Because my copy and paste skills are struggling with it, so.
I learned how to copy and paste quite literally when I was 4.
Well, I mean, I could do that. It's just if you don't get the right cells,
Yeah.
it seems to go further and longer and all that jazz. So.
I was lucky. My dad,
Okay, so
when I was little, he got the leftover computers that they're going to toss out anyway at work. And so, early 90s, we had a computer. So
yeah, I mean, I know how to
learned.
copy and paste. It just seems to go way across the whole Excel sheet faster than I need it to. Okay, so then I'm getting on the T. Okay,
Then you have to change the null hypothesis. That is in cell D10. You change the null hypothesis to 0.295. And then that's all.
And then the upper on the statistics, the mean, the standard deviation, and are just a blank.
What was that you said?
Sorry, I can't cut now. So on that upper box, the summary statistics, the mean and the standard deviation and the n are just blank.
Yes. Yes. Right below the title, it says please enter either the data or the summary statistics, but not both.
Our p-value is what?
You're kind of breaking up. I can't hear you super well.
I know, everything's cutting out. My computer only allows 2 hours. What did you get on the p-value?
The p-value? I got .006.
Are we happy in the p-value? Are we just taking 50% of it? Oh, because this has type.
Yeah, because it was .06, it's less than alpha. So I put for 34, the last one, the fourth one. We have evidence to say that the true mean is different than 0.95 or 295.
Okay.
Josh, what has happened to your sound? Something weird happened to Josh's sound.
You're not hearing Josh.
Oh, sorry.
Fall asleep on us there.
No, I don't know how I hit the mute button, but I hit the little microphone thing.
Oh,
What did you guys? So I cut out. What did you guys get for the p-value?
.006.
0.006.
Uh,
Because I got. Oh, maybe I did it.
did you double check?
Did I what? Oh, maybe this is a sign that our computer is.
Did you get it equal to?
Nope, I had less than. I knew it. Oh god, 0.006. Alright guys, question 34.
It's the last fourth one.
We have sufficient evidence to say that the true mean is different.
Uh-huh.
Cool.
Mm-hmm.
Alright.
Okay.
Guys, I think we're on our last set of questions.
Uh-huh. I already downloaded the AMPM file and I'm copying it into the Excel right now. There we go.
No, go ahead.
The
AMPM. Oh, let's go. It's probably. I'm using two.
I got 8.728. Go write that in. 8.728 to 10.455.
I did that one in SPSS, and that's what I got. For
And
T,
for
did you
P,
get? Go ahead.
I'm trying to remember where's the null hypothesis? Does it say? Or what's the type? Is it are taller in the morning than in the evening? Oh.
Steph, are you still with us?
Yeah, I'm just trying to get this file to open.
Yeah, mine. I'm gonna shut. I think I'm just gonna. I think it's. I have two computers on.
Great.
There it is.
Oh, it's less than.
This one is going to be a paired, right, with the difference?
Yeah, paired sample t-test. I think it's less than. I'm getting a 1 for the p-value. Oh,
I
wait.
think that's.
Let's see. For the T, I got 22.446.
Okay, that's what I got too.
For the degrees of freedom, I got 40.
Yep.
And for the p-value, I got 1.
Is it? Because I thought it was 0.001, but it's just rounded to 1.
Yeah, it's just rounded to 1 in here.
Okay.
I'll input it 1.00. 000.
Instead, I just. Can you put 1 or do you put 1.00?
I'm going to put 1.0 just to be on the safe side. Based on this, okay, because the p-value is greater than alpha, we fail to reject the null. So, based on the results of the test, there is sufficient evidence to suggest that the children are taller in the morning than in the evening. Yes, because we failed to reject the null.
Okay, that's one of them.
So what was the null here?
The null was the question is
if the children are taller in the morning than in the evening.
uh-huh.
So what do you put in? You just leave the null hypothesis blank?
Well, the null is the children are taller in...
Right, but for inputting the data, for the data summary.
Oh, it's for the inputting the data, I put less than, because it's kind of the opposite. Because...
Right, but what did you put for the null hypothesis? Just 0?
Oh, I didn't put anything for the null hypothesis. I just left it default. Who wants to be the brave soul to hit send first?
The brave souls. I kind of wish this was our test right here. I wish we could have like a group test.
I know.
So on this, the T was 134.8.
T, I got 22.446.
I did this one on SPSS and I got 22.446.
I'm going to have to do it that way because I don't know why it's not coming up with the...
Yeah, I had to do this one on SPSS when I did it. I'm going to try to, maybe tomorrow, I'm going to try to see if I can get really good at using Excel.
But then on the throughout all the class, it's easier to do it in Excel for me because it's just copy and paste, which is very easy for me. But then when you get to the quizzes, I have found, or the exams, they force you to do it in SPSS because the only files that they give are SPSS files, which is really poorly constructed for the class, I think.
They don't give you a chance to do it in Excel. They just give you an SPSS file.
Yeah.
Huh. Hopefully they don't do that now. I like my...
I just barely noticed that it was a trend this last quiz because I had to learn how to use SPSS during the quiz. Because before I was just using the Excel because it was easier.
So Josh, you did it. Did you do the paired sample T or did you do the...
it's the paired sample because I wanted to know the difference.
The paired. Yeah, I did the paired sample and then I did the... where you take the differences, so you have to do that whole new column where you make the differences.
Right.
Mm-hmm.
I remember how to do that.
I'm just gonna submit this and hope that it's okay.
Okay.
Do it.
Because I just want to hang out with my husband.
No, that's fine.